Welcome back to physics. We are in module 6 and we're talking about Newton's third law, which is action-reaction. Okay, so we're looking for action-reaction pairs, and basically what Newton's law states is that for every action there's an equal and opposite reaction. That means that when I have anything that collides, right, it's going to collide with the same force, or if I have two things that push apart, they're going to push apart with the same force. Let's look at some of this. Let's go ahead and go to our main screen here. So basically, for every action, there is an equal and opposite reaction. So equal, and opposite. Okay. For every action, there's an equal and opposite reaction. Let's look at our skaters down here. Okay. Now here on the ice, the skates don't have a lot of friction. Matter of fact, they're designed not to. But let's see here. If I circle this one here, see how this skate is pointed in the direction of travel, right? There's not going to be much friction on that. But this skate is at a 90-degree edge, and the edge, or a 90-degree angle, and the edge is cutting into the ice. So this is going to have a lot of friction because that edge is going to cut that ice. Okay, so what is the action-reaction pairs? Well, the action is the leg muscles here are going to be pushing backwards. That is our action. What is our reaction? The reaction is that the body of the skater is going to go in the direction that this skate here is pointed. Okay, so that's our action-reaction pair. And this is these folks are lining up to do speed skating. They're doing a race, and so again, they want to get as much acceleration as fast as they can to get up to their top speed, and then they'll maintain that top speed. Okay, so again, the action is the leg pushing backwards. The reaction is the whole body moving forward in the direction of travel. Okay. What else? What other action-reaction pairs? Well, here's a rocket. I think maybe I'm going to change my color here. Well, I've got dark and I've got light here, right? So let's see. So I've got a rocket here. I got a rocket there. This is heavy lift or lift heavy or whatever SpaceX is doing. This is where they had 3 Falcon Heavies. Falcon Heavy, that's what it is. They were put together, and they don't do this anymore because it's actually not the best way to do it. And then, so I've got the rocket that wants to go up, right, that we want to launch, right? But then I've also got the thrust coming out here in the flame. This is us throwing out. So which one's my action? Well, my action is burning that fuel and throwing it out the nozzle of the rocket. That's my action, right? And then my reaction is the rocket going up. Okay? And again, this is Newton's third law. Third law. So we have action-reaction pairs. You always want to be able to look for those action-reaction pairs and say, okay, what is the initial action? Well, the initial action is when I'm walking, when I'm pushing backwards with my leg. What's the reaction? My body moving forward. Okay? That's it. That's action-reaction pairs. We'll come back to in a minute and look at how this happens and how this affects acceleration. Be back in a minute.